All right, this is 8G3, 8th grade geometry, standard 3, and we are going to be describing the effect of dilations today. Here are a few terms to know. I'd like you to copy these down in your journals and please put a definition to them. A dilation is a transformation in which a figure stretches or shrinks with respect to a fixed point called the center of dilation. And we have a new coordinate notation rule today. It says for all ordered pairs x, y, we are going to take this scale factor called k and multiply each coordinate by that scale factor of k. And I'm going to tell you a little bit about that coming up here. All right, using this example, it says find the coordinates of the vertices of the image after a dilation having a scale factor of 2. Dilation again means we are either going to stretch this figure out or we are going to shrink it. And the number 2, the scale factor 2, is going to tell us what that is going to do to the triangle here. So the first thing we need all of the coordinates of the triangle, all of the vertices called A, B, and C. So let's list those on the side like we always do. All right, so A is 6, 2. B, -2, -2. And C is 6, -2. All right, now we need to figure out if this is going to be stretched or shrunk. You know, is it going to get larger in size or smaller in size? And we are going to use our coordinate notation rule that says for all of these coordinates in the original diagram, we are going to multiply it by the scale factor of 2 in this particular example. So we're going to take all of those coordinates and multiply them by 2. So we're going to get our primes. And simple multiplication. So we take 6 times the 2 is 12, and then we take the 2 times that scale factor, and we get 4. -4, another -4. 6 times 2 is 12, and -4. Now we're going to take our straight edge and our pencil and we're going to label our primes on the grid, and we're going to see whether or not this picture got larger or got smaller. So let's graph those points. So if this is 6, 7, 8, 9, 10, 11, 12, 4, 1, 2, 3, 4, we'll call that A prime. And then we have -4, -4. 1, 2, 3, 4. 1, 2, 3, 4. We call that B prime. And then we have C prime, which is 12, -4. If this is 12, then we go 2, 3, -4. We call that C prime. Take out a straight edge, and let's see what this new picture looks like. All right, so we have a stretch. So the original figure ABC has stretched. It has gotten larger with the primes. And according to the scale factor of 2, we have multiplied or doubled all of our original coordinates. We didn't double in size, we just doubled each vertice, each ordered pair at the vertex. All right, the next one says find the vertices of the image after a dilation having a scale factor of, this is 0.5. So let me move that up so you can see. This is 0.5, also known as a half. So we need to figure out what all the ordered pairs are, and then we are going to cut them in half. And then I bet you could kind of figure out what's going to happen to this picture. Um, what is it going to be? Is it going to be larger, smaller? Is it going to stretch larger or shrink smaller? All right, first step, let's get the original ordered pairs. A, B, C, and D. All right, so A is -2, +3. B is 1, 2, 3, 4, 5, 6, +3. C is also -2, but it's -3 going downward. So that means that D must be +6 and -3. Let's get the primes, and then we'll graph them. I'm just going to do this real quick for you for the sake of time. All right, cutting them in half. Half of -2 is -1. Half of 3 is 1.5 or 1.5. B is half of 6 is 3, and half of 3 is also 1.5. Oh, wait a second. I skipped, hang on. All right, I need more parentheses there. C and then D. All right, so C is going to be -1, -1.5, and then we have 3 and -1.5. I'm going to teach you, I picked this out on purpose. I want to show you how to graph fractions on these grid boxes. All right, so if we go -1, +1.5, we go back 1 on the x-axis, and then we go up 1.5 boxes. So we'll go, there's 1, there's 2, so I go up 1 and then a half, and I call that A prime. B prime is 3, 1.5, so 1, 2, 3, up 1.5 of the box. C prime is now -1, -1.5, so there's -1, there's -1.5, C prime, and then 3, -1.5. So 1, 2, 3, -1.5, D prime. All right, take out your straight edge, and you have a, what is that? That is a shrink of the original figure by a scale factor of 1/2. Now, again, I'm going to remind you, I'll say this often today, multiplying by a scale factor of 1/2 does not mean that this picture that I'm drawing right now is a half of the other one. That's not true. And I'm going to show you on our last screen. And here it is. One of our favorite hockey players here in Chicago. This is Jonathan Taves, and it says that there was an artist who uses a computer program to enlarge a design as shown, and they want to know now what is the scale factor of this particular design. So I've given you the ordered pairs already, and our job is to find out what the scale factor is, and we are going to use a fraction for that. We're going to talk about the width first, and then we're going to talk about the height from the new picture to the original picture. All right, so we're just using common math. finding out the distances using some grid points. All right, so let's talk about the width. Now, if you think about the axes, we know we have the x-axis and the y-axis. So your width is going to be how wide your picture is. We'll call that the x-axis, and the height, obviously, going up and down, is your y-axis. So let's talk about the width first. The width says, what is the distance between 2 points on the picture? So if I take the large picture and I am on the x-axis, I'm going to look at the x coordinates and how large or how wide is that picture. Again, we're on the x-axis, so I'm going to look at the x coordinates. So the difference between the points are 13 minus 7 over the difference of the width of the smaller picture, our original picture, which the width is, again, we're looking at the x-axis. So the difference between those two, or the length of them, is the difference. So 5 subtracted by the 2 would give me 3. And I know that I have 6 over 3, which is equal to, so we'll call it K. The scale factor is equal to 2 on the width. Now, just to check that, let's check out the height of this particular picture. And if we're looking at the height, we're looking at the y coordinates. So we have the 12 and the, oh, I'm so sorry. No, we're looking, sorry. We're looking at, I was going to circle over. We're looking at the height, which is the 12, and then we come all the way down here, and we're looking at the 2. So the height difference is 12 subtracted by 2 over, now let's find the difference of the height of the original picture. So I can take 6 subtracted by 1, and I'm going to end up with 10 over 5, reduced would be, again, K is equal to 2. So if I'm answering the question, it says, what is the scale factor of the design? Well, the scale factor is the difference between how large the new picture is in comparison to the original picture. And we took all of those ordered pairs and multiplied them by 2. Let's just check that. All right, check it out. Does it check? Fantastic. All right, now, what I also want to show you is that, I have it on the next screen. A common mistake says, if a scale factor is 4, that doesn't mean that the diagram is now 4 times larger than the original. And also, if a scale factor is 1/2, that doesn't mean, oh, I meant to put in there mean, sorry. That doesn't mean that the diagram is now 1/2 of the original diagram. What it does mean is that each ordered pair in the diagram is either increased or decreased in size, depending on the scale factor. Now, that's a lot of words. I'm going to talk more about that in class. It'll make more sense with another couple more examples. But if I'm looking at these pictures, let me clear off all this stuff. If I'm looking at these pictures and I just I created a rectangle here that is the size of the original picture, and I multiply it by 2, that doesn't mean that 2 of these are going to fit in. It looks like more than 2 are going to fit in here. So I have 1, 2, 3, actually 4 of the original pictures in there. So again, that's proof that the original is not 1/2 of the size. Because I had a scale factor of 2 didn't mean that I doubled the size of the picture. What it meant was I doubled the size of the width. Let's get that off. I doubled the size of the width using those ordered pairs, and I also doubled the size of the height. So if you look at the height, we doubled it, and if you look at the width, we doubled it. You put it together, it was actually 1/4 of the size. Okay. In your journals, please define the given terms. Write a few sentences on what you learned from this video. Again, if you have questions, class is the time to ask those. Never be shy. We're going to go over some application problems, and I'll see you in class.